Hello everybody, today we'll be doing merge interval given an array of intervals where interval I is equal to start and end. Merge in all overlapping intervals and return any array of non-overlapping intervals that cover all the intervals in the input. So let's check out the first input and that first output and see what we're dealing with. Here we have a 1, 3, 2, 6, 8, 10, 15, 18. What we're going to do is merge the 1, 3 and 2, 6 together to form 1, 6. A 10 remains the same because there are no overlapping intervals, and 15 and 18 have no overlapping intervals either. How do we know that there's an overlapping interval? The overlapping interval occurs when the end is greater than the beginning. So if this end here, the previous end, is greater than the current beginning, then that means that we have an overlapping interval. Okay, let's check out the second example and see what we can do. If there are any edge cases that we can think of. So currently here, let's check this one out. So this one, what we see here is a 1, 5, 4, 5, and they do merge because they are equal. So it doesn't have to be greater than, it's just greater than or equal to. So that's the first note that we need to make, like overlapping intervals are greater than or equal to the beginning of next interval. Okay. So what would be something like a edge case that we can think of? Well, some edge cases would be like having no intervals. Is that possible? The answer is intervals must be of length 1 or more. So no, that's not possible. We can only have the minimum edge case that we can possibly have is this. We can only have a single item. So that's our edge case, and we'll have to handle that when we do our code. What's another edge case is that interval I dot length is 2. Okay, that makes sense. Start and the end, and we have a starts at 0 and ends at 10,000. Okay, so that's all we know about this problem, and I don't know if there's any edge cases here. So we're gonna keep moving on to the time and space complexity. The time space complexity is going to be O of n because we're going to process every interval, and then the space is going to cost us O of n as well because we're going to have a result that is different from the intervals that we're currently working with. Alright, let's do a match. This is going to be sliding window, of course, because what we're doing here with every sliding window is that we are going to check how we're going to expand our window to the point where we can capture all the items and move the window when it no longer captures. And the window that we're going to make is exactly this. We're going to check, as long as there's overlapping intervals, we'll keep on expanding the window to collect more and more items inside our interval. So what we're going to do is plan expand sliding window as long as overlapping intervals at the end is greater than or equal to the beginning of the next interval. Okay, so that's basically it. And else, just add the next interval to our results, and we can and we'll do this. And we will continue to do this until we check, we go over all the intervals. Okay, I think that sounds like a pretty solid plan. Let's try it out. So what I noticed about planning is that it seems to be a lot like just like navigating myself. It's just like having a navigator, like what do you call that? Dual coding. Dual coding. I mean, like when you partner up and you code together, it's like kind of like that, where you have a navigator and a driver. So you're gonna play both the navigator and the driver. By playing the navigator, you have to plan, and then you play the driver and you're implementing. Give me a moment. I'm gonna go look that up. What that verb? Right. It was called peer programming. But we're having the navigator and the driver. Okay, let's check this out. Let's get results. Let's set that to our first interval, and we're gonna have use that as our beginning, and we're gonna start expanding our window. So we have a start and the end in intervals, and we're gonna move from the first item to the last item. We're gonna skip the 0th item. So what happens here is that we're gonna, if the window, the end, is, let's say, greater than the previous interval, the end, previous, let's make this easy to read, n previous start, no, previous start and previous end. Okay, let's check that out. We have that from our results at the previous spot. Okay, so let's check if the previous end is greater than the current start, then greater than or equal to, sorry about that, greater than or equal to, then what happens is that we increase our sliding window. So what that means is results at -1, we're going to increase the endpoint is going to be equal to the max between the previous end and the current start. No, sorry about that. The current end, because we're expanding the window size by the end. Here's what I mean. So let's look at this example. We have 1, 3 and 2, 6, right? We see that overlapping here, where the previous end is greater than the current or equal start. What we're gonna do is grab whether this end is bigger or this end is bigger, and we capture that. Reason being that, like, if suppose we have a 10 here, right? We don't want to take the 6, we want to take the 10. So that's why we have this particular situation here. Else, what we're gonna do instead is we're just gonna append this new result. So suppose that there is no overlap, and what happens here is we just make a separate, we just begin and make a brand new output, right? And so that's what we need to do. What we're going to take is append the start and the end. We're going to append that into our results. With that, we are ready to return the results. I'm sure that we have went over all our code. We will continue to do this until we go over all the intervals, and yes, that's it. That is all the code. And I think we have done this little slight review. Let's try to do the edge case to see what's happening here as part of our review. I'm not sure if it will work or it will not work. But what happens here is it looks like we just grab the results and we immediately return it, and nothing happens here. Unless I'm wrong. Yeah, I could be wrong, and I could be just, causing myself a problem. So let's test that code, make sure that I'm not wrong, and go from there. Alright, so I'm not wrong, and I think let's just run all the example cases. I think this should be good to go, and let's return. So, oh, we are wrong. Okay, so what happened here? we see that this is less than this one. So that means we forgot to sort. So what happened was that we needed to sort this interval. So let's run that code again. And I don't. Why would we forget this? How did we forget this? And how do we not forget this next time? So let me think about it. So the reason why we forgot about it is because of our short time using the understanding and looking at the few examples that we were given. And we completely forgot to ask if these were sorted, because these seem to be sorted in this situation. Of course, there is the edge case that we did not think about. So whenever you're given interval of items, make sure to ask if they are always sorted or not. I think that's a good question to ask, and that's something we will try to remember to ask next time. With that, let's do the evaluation, and let's see what we got. So O of n, what do we got? O of n, yes, time for each interval, and O of n space for storing each interval. And with that, we are done. Do you think we can do this in one single, like reusing the same array? And the question is, do we want to do that? I don't think we want code that like mutates the information that we take in, because when we take in like a list, it's a by reference, and when we modify the array, we're modifying the reference. That means the original list, and I don't know if that's a great idea. With that, I hope you enjoyed the video, and if you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.